Okay, so last Monday we discussed
inheritance. That was the last thing we did.
Yeah, so that was the last thing yenye tulifanya. So we discussed the key position and inheritance, and tulikuwa hapo kwa inheritance bado.
Actually tulimaliza.
Yeah, tulimaliza the hair thing.
Yes.
The hair where I inherited my sister's husband.
Yes. And after that, you heard about the evil love. You had two husbands, I think.
Yeah, we must equalize.
But then I've seen that there's a law that has been passed in South Africa to allow women to have more than one husband.
There's nowhere but it's also allowed in Kenya.
Yeah.
Which part?
No.
Legally, you can.
Legally.
Yeah, you can. You can get
Written
married
somewhere.
more than.
No,
it's
one wife, many husbands.
It's not written. It's not written as one husband, many wives. You are allowed to have polygamy. It's both ways. Polygamy means you can have more wives or you can have more husbands. That is still polygamous.
Yeah. Okay.
Or many to many. That is still polygamous.
Many to many.
Yeah, that is many to many.
Okay, so we can proceed.
Okay. You are not sharing your screen, by the way.
Oh. Share. So I'll choose someone randomly to take us through.
English, please.
Okay, sorry. I'll choose. Who will I choose randomly? Esther?
Yes.
So we are here.
She almost said present, madam.
Okay, take it off, Esther.
I'm reading, right?
Yeah.
Okay, so performance.
And explaining what you've understood from what you're reading.
Okay. Performance study. Defaults to false, in which case an operation that mutates, that is writes to the table obtains exclusive access, blocking any concurrent access of the same table until finished. If set to true, the table is optimized concurrent write access. Different objects of the same table can be mutated and read by concurrent processes. This is achieved to some degree at the expense of memory caption and the performance of sequential access and concurrent reading.
Just okay. On case I'm lost with the
Yeah, you need to explain.
Okay, so I was reading from where we have performance tuning. Or performance tuning, sorry.
Yeah, it's tuning.
Yeah.
Yeah, we in this case, In this case, we normally read this like a Bible. You just don't read it to the end. You don't read it like a storybook. You read it like a Bible. What I mean is you read, stop, explain, or say what you've understood, then we move on.
Okay, so in performance tuning, the defaults are set to false, and in which case an operation that mutates or writes to the table obtains exclusive access, blocking any.
Yeah. What does that mean?
In performance tuning, the defaults are set to false.
No. In this case, an operation that mutates the table obtains exclusive access.
So the operation is given an exclusive access, as in it is able to write
without using the same words. When you say an operation that mutates the table obtains exclusive access without using the same words, what do you understand by that statement?
is that we have a table, and when you're writing an operation, it's being given an access.
When you're writing?
An operation.
Just to step in, I think maybe what we need to determine here, what do you mean by mutate in the first place?
To change.
Change. So an operation that changes something in the table.
Mm. In this case, it's being given an access.
Okay, just to continue the guided thinking, what do you mean by exclusive access? Now that we know what mutate means, what do you mean by exclusive access? Just generally, exclusive access.
Content. But that is explicit. Explicit,
Yeah.
exclusive.
Exclusive access. What do you mean by exclusive access?
It means only the access only occurs to only one.
Okay. Okay, we're losing you, but it's okay. So the whole statement, in this case, the operation that mutates the table obtains exclusive access. What do you understand by that statement?
Oh, I think we've lost her.
Yeah. So what you're actually trying to do is to train on how to read and understand the documentation and how you can break it down just so that you can understand what's going on. So an operation that changes the table obtains exclusive access. So nothing else can happen because it's the only thing that can access the table. It's an exclusive kind of thing. So it blocks any concurrent access to the same table until it finishes. So if it was writing something, nothing else can write. If you set it to true, it is optimized so that you can have more than one process mutating the table. That's how I've understood it.
So I have a question. With the term exclusive, can I say it loudly says, like it declares there's something going on?
No, it locks. It just says, I'm using this right now. You can't use it.
Okay.
Yeah, it's like when you're calling someone and they're already on another call, or they're being called by someone else. They can decide that if I'm on this call, no other call comes through. So that is exclusive.
Okay.
Okoth, you had a comment?
Yeah, nilikuwa nasema like, it's like only people with permission, that is more like that. But in this context, a little bit different, but exclusive access means only people with permission. Meaning that, for example, if you go to a club, there's these exclusive clubs, or maybe even, even some clubs, some clubs that they have exclusive access where only members are allowed. But those which are also, like those which are inclusive, everybody is allowed in.
Okay, so I think we still lost Esther. Oh, you're back, Esther. Not yet. So this is achieved. So you can make it such that you can have more than one write to the table. Different objects of the same table can be mutated by different concurrent processes. That's exactly what you talked about. So you can achieve to some level, to some degree, at the expense of memory consumption and the performance of sequential access and concurrent reading. Okay, computer science stuff. I can attempt to explain, or I can nominate someone to attempt to explain. Jafet, I think you're a good nomination for this, assuming that you're doing computer science stuff.
Assuming that I remembered what I learned. This is...
Go on.
Okay, actually, let me repeat reading the question, the statement, so that I can understand better. This is achieved to some degree at the expense of memory consumption and the performance of sequential access and concurrent reading. Right? So, according to me, how I'm understanding this is when this operation happens or take place, is executed, there is some space that is being used, or a large amount of space, memory space that is being used. And also, when you set the operation to true, that is, yeah, that's how I'm understanding it.
Okay, just to add something on that. So remember, you can change this either to be true or false. When it's true, it means multiple processes can write or can mutate this table, right? But remember, whenever multiple things are trying to write this thing, there has to be some guarantees that there won't be any problem, like everything will just run smoothly. So this guarantee, to achieve this guarantee in quotes, so I think maybe the beam as a processor will have to find ways, maybe duplicating this table and all this sorts of stuff. So that is where I think memory consumption comes in. And then when you set it to false, that means you have sequential access, right? So you have to, this process has to write first, and you have to wait and doing all this sorts of stuff. Yeah, that was my version.
Yeah, so sequential means one after the next, one after the other.
Yeah.
So if you're reading something sequentially, that is exactly what you're doing. For you to read the word sequential, you start with S, then E, then Q. It has to be in order. Not the opposite, but something that is not sequential can be random. Random can be, instead of reading performance of sequential access and concurrent reading, you pick words randomly and read them. So it can be mutate, stable, achieved, concurrent, any, concurrent process achieved is some. So that is random. So the performance of sequential access and concurrent reading, concurrent means you can read at the same time. Now, you can achieve this at the expense of the RAM. So if you allow this to happen, then you'll be using more RAM and you'll be having some performance problems in the sequential access. That is my understanding. Yes, Tracy.
You haven't spoken.
Okay, Esther just dropped out, so you can pick someone. Go on.
I had a question, but then I realized that this is not a concurrency class. Then I think, yeah, because my wonder was in context of like the expense with concurrency. I mean concurrent reading and sequential access in context of performance. I don't know which one is better. I'm putting the memory aside. That is, I don't know whether I'm making sense.
Okoth, I like how you say that you're not going to ask it and you ask it anyway. That's okay. So, so I think without getting into the details of that, then what this statement is saying is turn this on, be aware that you're going to use more RAM and some performance is going to be affected if you turn this on. The performance that is going to be affected is the concurrent reading and the sequential access stuff. It's going to be affected if you're doing concurrent or parallel writing to the table. That's like the conclusion. So the internals of how all that happens might blow up my mind, so I don't even know what to think about it.
Yeah, that's enough for me.
Okay, now that Esther is still not here, I can read the next statement. Oh, there's too much noise from my side, so we can choose someone else. We can pick someone else.
I can read, then I'll pick someone else.
Right.
So the read concurrency option can be combined with the options read concurrency and decentralized counters. Okay, so there's the word decentralized counters, which is kind of confusing here.
I don't think we should care about it so much because we're not yet there.
Okay.
It's
So
one of the many options.
Okay. So you typically want to combine read concurrency with read concurrency when large concurrent read bursts and large concurrent write bursts are common. So for more information, see option. This is nice from someone. Okay, where does the next come? Where's the next one?
Please go and mute Getty. Go and mute Getty, please.
Wait.
Thank you. It's gone. Thanks.
Okay. So where was I? For more information, see option read concurrency. The decentralized counters option is turned on by default for tables of type ordered set with the write concurrency option enabled. The decentralized counters option is turned on by default for tables of type order set with the right concurrency option enabled. So for the order set, we have both decentralized counter being turned on and also the right concurrency being enabled. And the table decentralized counters option.
Maybe I think I'm reading this wrong, but what they're saying is for an ETS table of type ordered set and with the right concurrency turned on, only then is the decentralized counters option also enabled by default. Only if the right concurrency has been set, has been enabled. If right concurrency is enabled,
it's turned on by default.
So if the
right concurrency is enabled, then the decentralized is turned on by default for the ordered set.
Yes, exactly. Yes. I think maybe they twisted the fact that they've started with decentralized counters. Maybe that makes it a little bit twisted.
Yeah. So, and the decentralized counters option is turned off by default for all other table types. So for more information, see the documentation for the decentralized counters option. So are we together up to there?
Yeah, except for the bursts. Things I don't know when things are bursting. Okay, maybe we'll find it when we go through read concurrency. There are some bursts that were mentioned there.
So maybe we go further through the read concurrency, we can find more about it.
Okay.
So notice that this option does not change any guarantees about atomicity and isolation. We have two terms there, atomicity and isolation.
Computer science students, please come to our help.
Okay.
Computer science students, please help us.
Atomic operations and
isolation.
Yeah, Joseph is coming through.
Okay. So this is something that you find typically in database transactions. So it comes so these two terms come from database transactions and the way they're supposed to be executed. So it comes from this mnemonic that's called ACID. If you ever heard of that, if you ever heard of the term ACID transaction, then the A and the I stand for atomicity and isolation. So what atomicity basically enforces when you're creating any database is that when you're conducting more than one transaction, so if say you wanted to maybe create a user and then create their profile, what atomicity enforces is it's either all of them happen or none of them happen. So you can't create a profile without creating the user. You get? So everything in that
transaction. Can I say?
Pardon?
Continue.
Yeah, so everything in that transaction, or everything that is supposed to do with the right, or whatever is supposed to do, like if A and B are supposed to happen, then both of them have to happen. If any one of them fails, then the database resets back to like nothing happened. You get? So it's either everything goes through or nothing goes through. And then isolation basically means is that when you are modifying when you're making changes, is that these two, both operations of making the changes should be independent of each other. Like when you're changing A, it should not directly affect B. You get? So that each read or each write is independent on its own. It operates in its own. It operates on its own, like the word says, in isolation.
So you've introduced a certain word, transaction, and Sigu, being a student of agriculture, is wondering what is a transaction.
So, okay, so okay, so in database terms, you call a transaction as being not just it's like a set of tasks that should happen together, basically. You get like if you're supposed to do A, then B, do B, then do C, then the whole transaction is A, B, and C. Does that make sense?
Thank you. Let me go back to my carrots. Yes, it makes sense, Joseph. Thank you. I'm actually doing home science. Home science, not agriculture.
Okay, so I can repeat that point again. So note that this option does not change any guarantees about atomicity and isolation. So functions that make such promises over many objects, like the insert of variety 2, gain less or nothing from this option. It can either gain or it cannot gain. It can either gain from that or nothing. So the memory consumption inflicted by both write concurrency and read concurrency is a constant overhead per table for set. So I'm reading. The memory consumption inflicted by both write concurrency and read concurrency is a constant overhead per table for set, bag, and duplicate bag. So for ordered set, the memory overhead depends on the number of inserted objects and the amount of actual detected concurrency in runtime. So we have another term being introduced, the memory overhead.
What is overhead?
I have no idea what that is. I don't know what an overhead is.
About the head.
Can we say the limit, the memory limit?
Guys who did economic understand what overheads are.
And we can't use Frank's analogy because if I overhear something, it doesn't mean I heard it more.
Okay.
But the head here is an object.
Yeah, but Joseph seems to have an answer, an economical one.
Okay.
Okay, yeah, sort of, because it's sort of, okay, but it would make sense. So basically an overhead is some cost that it's not visible at the onset. For instance, if I told you, okay, just go fetch me a cup of water. So you might think that the only cost you'll incur is getting the water, but there are other related things that go into it. For instance, you will probably take your time, you will use some effort to go there and come back. So that's what basically an overhead represents. It's a cost that you cannot for sure tell at the onset, but they are playing a factor into it in terms of making either something work or not. Yeah, you might even have to wash the glass, yes. So that's a cost that at the start you don't know, but it can occur, which can probably inflate your cost and everything else. So it's basically something that it's hard to trace. It's a cost that is hard to trace.
So you don't know what is on top of your head.
Yeah.
So when I remove the word hard to trace, so we can say overhead is a cost.
Yeah, sort of.
A cost that you don't know about.
Yes.
Yes.
Okay. So they're saying the cost depends on the number of inserted objects. That is one ordered set. An ordered set. Okay.
Then we told the memory overhead can be especially large when both options are combined. Okay, so I think we are together up to there.
That note. What is that note? Prior to?
TP22.
Prior to standard lib 3.7 or TP22, rate concurrency had no effect on ordered sets. So I think it has effects on OTP and OTP.
OTP20.
For OTP23 and above.
Okay.
Okay, is there a way we can try this out in our EX?
The right concurrence.
Yeah.
Yeah, but I don't know
We
how
will
we
never
can test it.
We will never see it, yeah.
Oh.
And yeah, just to add something onto that, the reason I sometimes like reading through search is I might never use it at this moment. I might never need to use it, but somehow in the near future, when you're supposed to do something, just somehow you remember that there was some cost implication of having write access or enabling concurrency or all that. So we might never use this at this moment, but you don't know when you need it. Sorry, I'm having a little pointer today. Pauline.
So I'll pick on someone next to take us to the read concurrency. So who will I pick? Joseph?
Sure, no problem. So read concurrency and Boolean. Eh? So performance tuning, it defaults to false. When set to true, the table is optimized for concurrent read operations. When this option is enabled, read operations become much cheaper, especially on systems with multiple physical processors. However, switching between read and write operations becomes more expensive. So I think here they're saying, well, when you're optimizing, like you want only your ETS table to be a read table, then there are some performance benefits. How, I'm not sure, but they're saying they're much more pronounced when you have multiple physical processors. And then, of course, they also mention that switching between read and write is expensive. I think because you're going back to what was there before, write concurrency, which is probably not ideal. So you typically want to enable this option when concurrent read operations are much more frequent than write operations, or when concurrent reads and writes come in large read and write bursts. That is, many reads not interrupted by writes, and many writes not interrupted by reads. So you could think about this if you're only doing inserts that you don't need return from. I don't know if you've ever had those inserts, like where you just insert, but you don't care about the response. Or where you're doing an update and you don't care about the response. So then there's those ones that have like, you insert, then you get what the table inserted. Like for instance, maybe fetch back the ID or something of that sort. So here they're just saying it's best when you have pure operations. Like it's only inserting, you don't care about the outcome, just care that it inserted and said it's okay. And something like that. So you typically do not want to enable this option when the common access parent is a few...
Just to interrupt. Okay, in order to add something. So whatever we read up there about the concurrent read bursts and write bursts, Okay, to my understanding, it's something that, okay, like the way they have explained it. So whenever you are writing, that is the only operation you are doing. So this is it's going to be expensive when you are writing, and then there's another process reading, and then there's another process writing. The moment they are interleaved, then this becomes more expensive. But if it's just some bulk operation, like for the next 10 minutes, all I want to do is write, then it will still be okay.
Exactly. So you typically don't want to enable this option when the common access pattern is a few read operations interleaved with a few write operations repeatedly. In this case, you will get a performance degradation by enabling this option. Option read concurrency can be combined with option write concurrency. You typically want to combine this when large concurrent read bursts and large concurrent write bursts are common. So basically, the last paragraph and the second paragraph say the same thing.
I think we should now care about understanding what the read burst and write burst mean.
I think that is what they said there about, okay, maybe I think the second paragraph, they said, you typically want to enable this operation when concurrent read operations are much more frequent. So when that concurrent read operations are more frequent, right? A burst, something, it's many at once. So I think that is what a concurrent read burst is. And then a concurrent write burst is when the write operations are many at that given moment for a given time, a given period of time.
I can explain what is meant by a burst. So if you've ever been to our office, you'll realize that sometimes there's a lot of silence, but at about 11 o'clock, someone just starts screaming. So a burst is a moment of silence or no activity or nothing. Then all of a sudden things start happening. That is a burst. The opposite or something that is not a burst is consistency. If three people are consistently screaming from 8 o'clock, then there are no burst of screams. But if there are three and at a particular time or at an undetermined time, it gets from 3 to 15 or 20, then that is a burst. Oh yeah, and it has to be not really consistent, but it has to be, is it okay if I say a burst is a collection of spikes?
Collection of?
Spikes. If it happens once, it's a spike. Yes.
Yes.
But a lot of spikes can be called as a burst.
Yes.
Yes.
I'd agree with that.
Okay. Just if you can pick someone randomly.
I've just remembered there's a dog in Tom and Jerry called Spike. It's not that dog that you're referring to.
Pardon?
I'm seeing there's someone.
I'm saying if you watch Tom and Jerry, there's a dog called Spike.
True. So I think we can go with David if he's up for it. Read next.
David, are you out of the water now? He was drowning in the morning. Seems not.
Okay, then maybe Nuku.
Yeah, seems he didn't hear you. Nuku, are you in a position to speak?
Yes, I can talk.
All right, awesome. And yeah, we don't know who screams at 11, but it's very consistent every single day.
I see. Interesting. Okay, we are the decentralized counters, right?
Yeah.
Okay, good stuff. Says performance tuning. Defaults to true for tables of type ordered sets with the right concurrency option enabled, and defaults to false for all other table types. This option has no effect if the right concurrency option is set to false. Interesting. I think it's some kind of performance stuff as it's saying, but how it works in practice is I can't really tell from here. But it seems to be affect only. No, it seems there's a default for ordered set type of tables. Yeah, and something different for other table type, but I can't really tell from that line. So maybe the rest will give us some idea about what it means.
Actually, this first paragraph, I think we actually read it in the previous option. That is with the right concurrency and the read concurrency. So maybe this second paragraph will tell us more about what it is.
Okay, cool. Let me get to that one. Okay, when this option is set to, the table is optimized for frequent concurrent calls to operations that modify the table's size. Okay, and its memory consumption. Example, insert and delete. The drawbacks is that calls to info1 and info2 with size or memory as a second argument can get much slower when the decentralized counters option is turned on. Okay.
Whoa. Okay. I think I'm still not getting this. So is it a count? What is a counter and what is? There are two things here. We have a decentralization and we have counters.
And you have?
There are two things involved. There's a decentralization of counters. So we have the decentralization and we have counters. So maybe this, what does decentralized mean actually? I wanted to explain, but I realized I don't have a meaningful answer. Decentralization, blockchain is decentralized.
Okay, we can
A
look
decentralized
at
government.
Snake has many heads. When you chop one, the other grows back. Like from my understanding of decentralized meaning is that actually there's not truly one point of operation. So every person act as an independent, that is. Maybe they can communicate once in a while, but everybody makes his or her decision independently.
Okay.
Yeah.
So it's kind of like you have a parent and grown-up children.
Exactly.
So the grown-up children are responsible for their own actions and do whatever they want.
Yeah. But yeah, something like that.
Okay. I know that this counters. So maybe we can find that in the next paragraph. Does anybody have any idea of what they mean by these counters?
Okay. it's on the next paragraph, it says that when this option is enabled, the counters for the table size. So I think that counter is referring to the table size. Yeah.
So the counters for the table size and the memory consumption.
Yeah, exactly. Are distributed over several cache lines, and the scheduling threads are mapped to one of those cache lines.
Okay, actually, now I'm getting it. So in the second paragraph, they're saying, so when this option is enabled, there are some actions that are optimized. And specifically, these are actions that concern the size of this table or memory consumption.
Yeah.
Yes, so it only optimizes those two things. Operations that modify the size or memory consumption.
Yeah. Okay. Okay, there's another thing. It says that the L option plus DCG can be used to control the number of cache lines that the counters are distributed over.
GCD. DCG. Wait, this is the opposite of GCD. Okay. I don't know what DCG is. Maybe it's the opposite of DCD. Who knows?
LCD.
Okay, God is dropping on. Control the number of, I think maybe we could say this is a meaningful abstraction unless we want to indulge ourselves into DCG. Tracy, maybe you could, because we have 6 minutes left, so maybe we could have a look at what DCG is for that remaining time.
Okay, I'm highlighting there.
So the first thing is
this is the page that have been directed to me.
ERL command.
It's a combination, seems like a combination.
Like an option.
Yeah, because we have the plus A plus B plus C capital plus D. Oh, here it is.
A decentralized counter groups limit. What's the L? Why did they not put that L on that city? So it limits the number of decentralized counter groups used by decentralized counters optimized for update operations in the Erlang runtime system. By default, the limit is 256. Okay. When the number of schedulers is less than or equal to the limit, each scheduler has its own group. Okay, I think now I'm lost. I don't understand what the second paragraph is talking about. We started going to the schedulers. Okay, but from the general point of view, DCG controls the limit for those cache lines that we've read. Yeah. And the default limit is 256. And by the way, what does this ERL command do? I think I've once seen if you check
it's
if you check
IEX for it's IEX for Alan.
Yeah. Wait. Is it IEX? Okay, is it like the IEX? Because I think there's this server process. When you check the server process that is running, I think you'll see that it's that ERL as well. Unless I was seeing my own things.
So it invokes the code for the Alan emulator, the VM.
Okay. Okay. I think that sums up our meta for today. Let's see.
Thank you.
Oh, actually, this was the last option.
We have the compressed option.
Okay. If this option is present, the table data is stored in a more compact format to consume less memory. However, it will make table operations slower, especially operations that need to inspect entire objects, such as match and select. They get much slower. The key element is not compressed. So it's kind of just compressing the table.
I wonder how it compresses the table data and leaves out the key element.
Yeah, it has to leave the keys. So the key needs to remain uncompressed so that you can use the key to look up the values.
I think also there's an advantage of keeping it uncompressed because of, as I said, it's more performant this way. Because if you compress it, then match and select are much slower. Because I think you have to decompress when you're matching.
Yeah, because if you compress all your keys, then when you want to, as you said, do a select, you might have to uncompress all the keys for you to find something.
Right. ETS. Yeah, well, I think this was the most important part. This is like the most important part when you're dealing with ETS tables. Yeah, this was the last iteration concerning the ETS tables, right? Do you have another one next week?
Yeah.
Concerning this same ETS?
No, this was the last topic that we had to cover.
Based on ETS. Yeah, I think whatever you covered with that new is fairly more than enough. And not enough, but I think right at this moment now you can feel comfortable now to use it. The most important parts there were the write concurrency, read concurrency, the name option. Which other one am I forgetting? I think
access right.
Yes. And there's this thread in Elixir forum. Let me share it here. Oh, I'm not in the call here. time you can conclude.
Mhm.
Okay, so okay, you can see from the chat someone is suggesting we do amnesia as from next week. So I guess as from next week we can deal with amnesia. Is that okay?
Is it amnesia or goodness?
Amnesia.
Pardon?
Kizungu.
Where's the A?
Amnesia.
Where's the first A that you're adding? Okay, now bye guys.
Okay. Okay, bye.
Yes.